Hi, I'm Andy Shaughnessy for Real Time with SMTA. Here with me this afternoon is Dr. Mehran Maalekian from AIM Solder. How you doing?
Good, thank you. How are you?
Well, good to meet you.
Good, thank you.
Thanks for coming. Mehran is the R&D manager for AIM, and I understand you're presenting a paper tomorrow.
Correct. Tomorrow, a paper about the alloy development.
Okay.
Yeah. The paper I'll talk about is about developing a new alloy which is up for high temperature and also demanding application like harsh environment, where the standard lead-free alloys like SAG would not perform as well as this alloy. So,
right.
Yeah. So this alloy that I'll talk about tomorrow in detail in conference basically addresses the shortcoming of SAG alloys, which are low creep resistance and degradation of mechanical performance at harsh condition. Mm-hmm. So we have realized the shortcoming of SAG are actually by aging is becoming worse and worse because of the coarsening of so-called these intermetallic particles by time that causes this problem with SAG, and we have tried to overcome that by adding some alloying addition and some micro-alloying elements to overcome this problem. Right. So yeah, that alloy that we will present tomorrow and also is also commercialized is so-called REL 22, and this alloy has some bismuth addition to that. Bismuth, adding bismuth to certain level will improve the strength, hardness, and reliability of the alloy. But the problem with bismuth, if you add a lot, then you get the brittleness problem and the alloy becomes brittle. So we have optimized the amount of bismuth we can add. Yeah. But in top of that, we have added some other alloying element like antimony and a couple of more micro-alloying element or dopant to control the thermal behavior as well.
Right.
So yeah, that alloy, that's a multi-component alloy system which has been developed through a close collaboration with university and some PhD and postdoctoral fellow as well, and has been running through different testing as well, and has been proven that it works very well in harsh conditions.
Yeah, that's good. Well, you guys are you guys are staying ahead of the game with the different kinds of alloys. So. Right.
So this is actually has been like about 6 years we have been working on developing new alloys, and it's quite challenging, to find out an alloy that behaves well not only mechanically but also in terms of manufacturability, because you can have lots of good mechanical performing alloy, but very hard to have also good printing performance, good wetting performance, and that's quite challenging, and we have been doing a lot of research to find out the best compromise between printing, wetting, mechanical performance, and harsh performance conditions.
Okay. Well, it sounds like a pretty good paper. Let's see if we get up there.
Yeah, I'm excited to present the paper tomorrow, and I'm expecting some questions from audience as well. So of course there will be lots of questions or concern about when we talk about high reliability application. Always are concerned about thermal cycle, creep, drop shock performance, and so forth. So we are actually doing lots of testing to answer those doubts and questions as well. So yeah.
Okay. Great. Well, I'm glad we got to meet you.
Okay.
Appreciate you coming by.
Thank you very much.
Again, I've been speaking with Dr. Mehran Maalekian. I'm Andy Shaughnessy. Real Time with SMTA. Thanks for watching.